Hey everybody, welcome back to Spacecast. This is it. You made it. And again, with us is Bob Hall. He's been here a couple times before, giving us some interesting topics to talk about. And Bob, today is no exception. Bob is going to give us a rundown on an interesting satellite that is fairly active as far as satellites go. Bob, I think it's not stepping out of line to say that you're probably our most popular guest so far. Get a lot of fan mail for you. Care packages sent and everything, so
nice.
That must make you feel good. And
sure.
It's probably why you came back, which we certainly appreciate.
Keep the cards and letters coming.
Yeah. What's your favorite kind of cake that you want to get as a... All right, so today Bob's joining us to talk about something that he's seen up in the Counterspace. And again, Bob is the Director of Operations for the Commercial Space Operations Center, the Counterspace. And today he's going to talk to us about a satellite that they've seen do some interesting things. It is a Chinese experimental satellite known as SJ-17. I'm not going to try to pronounce it. I'm just going to say SJ-17 and leave that to Bob if he wants to cross that bridge and try to say it. But you don't have to. No pressure. I can't say it. I know I can't say it. So Bob, let's hear about this. Let's see what do you got.
All right. So not that it matters, but the way we most likely, compared to Chinese, butcher it as we say Shenzhen 17, but I think if you try and Google it and play a pronunciation, it doesn't sound anything like I just did. And traditionally, we've noticed that they tend to label their test or experimental satellites with Shenzhen and various numerologies, as opposed to one of their operational missions. Not that you could take that to the bank, it's just a pattern that it seems to hold up. I think if you look at the translation, again, based on what Google will tell you, there's lots of different translations, but some of the translations for Shenzhen are test or practice, and they kind of support that theory of what this, how this is compared to an operational mission. So this satellite, new Chinese tech demonstrator, was actually launched in 2016, so starting to be not new. And when they announced the mission, they announced several different things that the mission would do. I've left off a few of them, but it did specifically talk about orbital debris observation at high altitude, potentially including rendezvous and proximity operations, and low thrust technology. So we saw all that, and we realized that this would be a satellite that would be behaving in unusual ways compared to most of the other GEOs. And so we said, this is going to be an interesting satellite to watch. And we watched it basically from launch on. It was actually the maiden flight of the Long March 5 back then. And then we've tracked it ever since it was injected over the Americas on November 3rd or 4th, 2016. So I'm just going to step very quickly through what happened at the beginning of the mission. So the first week or so, as I said, it injected over the Americas over here, and you see two orbits. These orbits are drawn in the Earth-fixed frame, so that's why they look kind of loopy compared to a standard GEO, which is that white ring. The satellite itself is the cyan, and the yellow is the upper stage that placed it there. So you can hopefully tell from here that perigee for both is down around GEO altitude, and they both had an apogee higher than GEO altitude. As a result, they were walking west over time, one a little bit faster than the other because they actually slowed the satellite down. And so they started walking across the Pacific. And then the 11th, 12th of November, again, now we're looking at the orbit of SJ-17 coming in, and they've done several maneuvers here, these changing the drift rate, changing the inclination. And this guy in yellow you see here is a satellite called ChinaSat 5A, which was an older Chinese communications satellite sitting there.
Again, just to orient the view for the audience, is the green box is...
it's the station for ChinaSat 5A, where it kind of lives.
How many kilometers across is it?
It's about plus or minus either 37 or 73, depending on the satellite. Sometimes as they get older, they tend to take up wider swaths. I think this one was plus or minus 37.
Cool. And that's drawn in the Earth-fixed frame.
So the other thing is that, so this drift was occurring from the 4th of November to the 11th or so as they were coming across the Pacific. Using some of our other tools that we're not going to get into here, we actually identified 3 or 4 days prior to its arrival here that this was very likely the target for the rendezvous sequence. In other words, we had high confidence that they were going
Saw
to
it coming.
rendezvous with ChinaSat 5A.
You saw it coming.
Yep.
Based
yep.
on the maneuvers you were tracking in real time.
Based on the maneuvers and again, some space object threat assessment, which is one of the tools that AGI sells now. Back then, we didn't sell it, but we've had it in ComSpock for quite a while. So moving right along. So they got there, and then they kind of parked to the west of ChinaSat 5A. And now this is depicting kind of what the typical behavior looked like. This is just a couple of revs, so it's only a few days, even though the chart talks about a month's worth. And what I've done here is I've changed the orbit of SJ-17 to draw it relative to ChinaSat. So they basically were in the same plane with a little bit of east-west motion throughout the day.
That's the light blue.
Right, the light blue, and ChinaSat's still the yellow one. You can see where I took this snap, they were, what is that, 163 kilometers to the west of it. And that was kind of typical. They hung to the west of it for several weeks and they moved in and moved out and did various things. And then between the 3rd and 6th of December, they actually started to walk in. So you, again, still relative. You see I'm making these loops in. And then from the 7th of December to 27th December, this is back in 2016, they were in a circumnavigation, or we say circumnav, where ChinaSat was going up and down every day, and SJ-17 was going around it every day, just going around it. So that basically they had achieved a rendezvous and were doing some proximity operations testing. So that was right after launch. They went and did this. Clearly, it seemed like it was a high priority of one of their test objectives. Then this situation kind of ended on the 28th of December, not because SJ-17 left, but because ChinaSat 5A left. So that was interesting. So they did this for a month or two, and then ChinaSat 5A departed. And this is a little snapshot. You see ChinaSat 5A starting to walk away. This is one day and a half, and it's going to keep going. And
he stopped in his slot eventually, or?
Well, he went somewhere else.
Okay.
So SJ-17 stayed there until April, and then SJ-17 departed. And then, before we get to that, let's talk a little bit about the longitude of these two guys. So again, you can see SJ-17 here is purple, and the bright green is ChinaSat 5A. So SJ-17 is hanging a little bit to the west of ChinaSat, gets close, backs off, does all kinds of things. And then that period, December 3rd to 6th, like I said, it kind of walks in. And then you see this kind of crisscross pattern.
Very close.
They were in a circumnav going around it, and eventually ChinaSat 5A left. That's this green line departing, went to the west. So you said pretty close. Here's how close it was. So again, they arrived. They were hanging out 100 kilometers, got as far as 250, down well below 50. And then when they got into the circumnav, you see it kind of drops into this very regular pattern of between about 50 and 100 kilometers as they were in this oval, a 2-for-1 oval around ChinaSat. So again, they demonstrated, like we thought.
Sophisticated stuff, yeah.
Yep, we demonstrated they were doing rendezvous and prox ops. They were capable. So presumably they had a way to look at their target. So they I don't know this, but I'm guessing that when you do things like this, there's a certain amount of onboard autonomy that you'd want to have or test out. And to do that, you need sensors to tell the autonomy what to do. Again, I'm just speculating there based on what I see here. Then, as I said, ChinaSat 5A left. In April, SJ-17 left that spot, and in June arrived over here next to ChinaSat 6A. And parked slightly to the west of it. And this is just a still shot. Interestingly enough, you see on the right-hand side of the screen, this is actually ChinaSat 5A's new home. So this is where it went when it left in December. But they came and they parked a little bit to the west of 6A, not really that close, and they were here till right around the end of September, beginning of October. And they never really did anything as interesting as what they did with 5A. They basically just kind of sat here tens of kilometers away. I believe if you look at this is about 60 kilometers where this snap was taken, and that's about where they hung out. So each of these little green lines, I think, is 10 kilometers. So they stayed there for a few months. Okay. Now fast forward to early 2018. and there was a satellite called ChinaSat 20 that was older and had been retired up to the super sync belt. It was no longer stable. It was drifting around the Earth. That's in yellow in the background there. SJ-17, meanwhile, started to drift to the east, and right around here, SJ-17 increased its inclination, so that up and down squiggle you see is commensurate with the inclination. And they've increased their inclination, and we watched, again, as this happened, and they got around to the international dateline, and in a period of 12 hours, SJ-17 did 2 fairly large maneuvers and completed a course rendezvous with ChinaSat 20. Now, because ChinaSat 20 was up above GEO, they stayed with it. And then we're going to zoom in here and get a little bit of sense. Now we're drawing the dot relative, and they bounced around and went all around it, sometimes single-digit kilometers, sometimes less than a kilometer. This was quite interesting.
That's pretty close.
They stayed here for about 6 weeks, here being in the neighborhood of ChinaSat 20. So this was certainly their longest or most interesting set of proxops. There were times when they were really, really close, sub-kilometer close to ChinaSat 20. And interestingly enough, as that whole engagement started, we saw ChinaSat 20 start to maneuver again. Remember, it was retired a few months earlier. It started to maneuver again. It got stable again. So clearly they were controlling it in a cooperative fashion for these test purposes. So this marked then the third rendezvous with a Chinese object. Moving ahead to the fourth one, I think we've talked about this in the past. ChinaSat 1C anomaly we saw last summer 2018. Here's just a touch on that again. Here's a plot of the longitude of the two. So the green is ChinaSat 1C, which was working fine, had a little issue and started to drift to the west. And then SJ-17, which had been kind of in the neighborhood, came rushing over, parked next to it, and we've kind of zoomed in over here, parked next to it, and then did something, and then they were able to turn ChinaSat 1C around, and SJ-17 went with it. And after they got part of the way back to where they came from, SJ-17 left. So this was I'm going to say a probably not intended rendezvous when they launched a satellite from there, but I guess they figured it was sitting there and they'd already demonstrated it, so why not put it to good use? Again, presumably if it can do rendezvous and stuff, it has some ability to sense, and so they must have used that sensor for some reason. Figure out what's going on with ChinaSat 1C, right. So that was the fourth one. And then since then, this is just kind of 2019 at a glance, and you see they're just kind of station keeping. They're sitting at 94.2 degrees east, station keeping these blue lines of maneuvers. They did some interesting things back in the March through May timeframe where they actually went a couple tenths of a degree over to the east and then came cruising back through their station over to the west. For about a week or so, they stayed there. It must have been a target they cared about. It wasn't very long. It was only a week. And then came back to 94.2, and that's where they've been hanging out. So not a lot going on, but they have done some, little things in 2019.
And that big change that you see in the middle there, that's pretty small compared to the previous maneuvers that had done.
Right. You look at this as 93.7 to 94.5, so that's only 0.8 degrees of longitude. And here we have the entire mission to date. So I'm plotting longitude of SJ-17, and I apologize, but when it goes over the international dateline, you get this vertical black line because we go from minus 180 to plus 180. So that happened in the beginning of the mission. And here's where they were next to ChinaSat 5A. And then 5A left, and they stayed there for a few months. Then they went and rendezvoused with ChinaSat 6A, and then they left and parked nearby. And then this was, I showed you that movie where they started drifting to the east, and they rendezvoused ChinaSat 20 right around the international dateline, which is why we see this black line wrapping from minus 180 to plus 180. And this whole slope time, they were with ChinaSat 20 as it was drifting. They broke off, and then they went to find a new home. And then this is the little thing they did with 1C. And on a scale like you just talked about, here's all of 2019 on the right-hand side, which looks like a flat line. It's only when you zoom in that you see any structure to it. So in summary, we've seen them do rendezvous and proximity operations with 4 different older Chinese satellites. I'm going to call one of them unplanned, 3 of them probably planned, and they've been largely quiet since then. So the one thing I do want to point out, in 2018, so on this plot, it's kind of the middle of the plot, right before the green section till past the purple section. If you look at the delta V expended by all GEO active satellites, the bulk of all GEO satellites are 100 meters per second or less for the entire year. There may be 1 or 2 that kind of cross 100, but not by much. SJ-17 was far and away the guy at GEO who used the most delta V. I believe it was between 700 and 800 meters per second in 2018. So they were easily the most active in terms of delta V expended satellite in GEO.
That's very interesting, Bob. Thank you very much. I think you were going to show a little simulation at the same time too.
Sure.
It's always cool to see it in action. The snapshots are very revealing as well, but sometimes when you see it move, it helps tell the story.
So this is the initial, when they got to 5A, Transat 5A back in November 2016. Notice how they matched the plane. So again, we're zoomed way in, but these guys are going up and down kind of in a synchronized way. But that's a function of their inclination. If I drew these orbits in the inertial frame going around the Earth, you'd see they're both tilted pretty much exactly the same. So you can see they stayed to the west for a while. Let me just pause it, and I'll just scrub the time to go through. They stayed to the west. They got a little bit closer. It's hard to see, but if you kind of look at the distance while I'm scrubbing it, they're 100, 200 kilometers to the west of it. And then as we get to, now you notice they're getting close and far. They backed off a little bit, and now we're walking in, and now they are, even though it doesn't look like it,
yeah.
This is where they're circumnavigating it. Again, remember, I'm drawing them both.
Can you
Earth
pause it
fixed
and
frame.
rotate so that people can see a different perspective for that one?
Yeah, so what happens at this time of day, they're to the west of it. And here they are closer to the Earth.
That's cool.
And now they're to the east of it.
Can you zoom on them a little bit? That's cool.
So if we change it to a relative frame, this will probably be much more intuitive.
So now the blue is being drawn with respect to the yellow.
Yes, and there's the Earth. So if we look down on it, this is a classic 2-for-1 oval. It's 2 this way, 1 this way. So this is, I believe this was plus or minus 200 kilometers and plus or minus 100 kilometers. And as we play that.
That looks neat.
So they clearly have demonstrated an ability to rendezvous and operate with respect to another target. They've tested it out with, again, at this point, multiple older Chinese satellites. Don't know what the future holds or what this means for this technology in terms of folding it into operational programs. No idea. But it's pretty interesting because, it turns out a lot of the satellites at GEO are comm satellites that are designed to go park in a place and spend most of their life there. And occasionally they go to another place and sit there. So this is an interesting type of mission to sit back and watch.
Yep. Pretty highly maneuverable from a GEO perspective. Yep. Oh, Bob, thanks again for filling us in on some of the stuff you've seen. And I am sure you're going to keep an eye on this one. If it does anything interesting and new, you'll come back and you'll talk to us again, I hope.
Yep, sure.
And always appreciate it. Thanks a lot. Thanks, everybody. Thanks for watching. Hopefully you learned as much as I did.
All right.
All right. Thanks, Bob. See ya.